Good afternoon, everybody, and welcome back to NASA's Wallops Flight Facility here in Virginia. I'm NASA's Josh Byerly. We're going to be taking a look at tomorrow's test launch by Orbital Sciences as they get ready to test out their Antares rocket, as well as getting a weather update. We'll also be talking today about Orbital Sciences' progress over the last few years as part of NASA's Commercial Orbital Transportation Services program. To my left is Alan Lindemoyer, NASA's Commercial Crew and Cargo Program Manager at the Johnson Space Center in Houston. We also have Frank Culbertson, the Executive Vice President and General Manager of Orbital Sciences Advanced Programs Group. He's making his encore performance today with us. We also have Mike Pinkston, the Antares Program Manager with Orbital Sciences. And we are also joined by John Dickerson, the Test Director for tomorrow's activities here at Wallops. We'll get started with Alan.
Okay, thank you, Josh. Well, it's been about 5 years since we started our program and our partnership with Orbital in the COTS program, and there were 5 short years, Frank, to take that beautiful graphic. It's always exciting to see your view graphs come to life, and when you drive out to the pad today, we certainly can see that. Brand new launch pad, a beautiful rocket, and it's certainly been an amazing 5 years. We began the program with several objectives. The first was to apply NASA strategic investments to stimulate the commercial space transportation industry. And I distinguish the transportation industry from the broader commercial space industry because it really implies transporting products and cargo to a destination in space and then potentially bringing that back, as opposed to just launching spacecraft or satellites, which has been a thriving industry for years. So ours was focused on the space transportation. We would do that by opening our vast resources at NASA, facilitating access to our expertise and our facilities and our equipment, and make that available to our commercial partners with the goal of achieving safe, reliable, and cost-effective access to space and to low Earth orbit and this International Space Station in particular. And if we were successful in doing that, we also recognized we needed to create a market environment that would sustain this emergent new capability and make that environment, help create that market. And the International Space Station provided a perfect market for these new capabilities with reliable and predictable needs. And we followed through with that commitment because shortly after our award, by the end of 2008, we awarded Orbital and our other partner SpaceX commercial resupply contract to service the space station. And in Orbital's case, they were awarded a contract for $1.9 billion and 8 resupply missions through 2015. We could bring up chart 1. Okay. Now, under the initial agreement with Orbital, we were to make incremental payments up to $170 million for the successful performance of a series of milestones that we pre-negotiated under the agreement. Those were a series of 19 milestones that were to culminate in the demonstration mission to the International Space Station. Now, because we had limited funding in this second round of competition, we just didn't have the capability at the time to provide assistance and funding for multiple flights. Of course, that would have been optimum. But as 2010 came rolling around and it quickly became realized that the space shuttle would be retiring, the services of resupplying the space station from our American soil was critically important. We began asking the questions, what could we do to reduce risk and improve the chances of success that our commercial partners would be able to provide these services? And in consultation with Orbital, it was determined the best possible thing we could do to improve our chances of success was to add a test flight, because testing is so important. And should there be a problem in these initial flights, we certainly wanted the capability and the opportunity to be able to give it another try. So In 2010, we requested funding, and in 2011, we were appropriated the funds to add in the additional risk mitigation milestones. Those were a series of 10 additional milestones that Orbital has performed over the last couple of years. We added $118 million and the ability to add the test flight that we're about to see tomorrow. So we have left in the agreement 4 milestones. The flight tomorrow is one of the 4. And we have a payment of $4 million on that milestone. And then there will be 3 more that will lead to the demonstration to the International Space Station in a couple of months. And that'll complete our COTS agreements. This does represent a new way of doing business for NASA. NASA is not directing the design in this case. We are a partner, we are an investor, we are a technical consultant, and we're a resource to Orbital to help them in many ways. And we have reached back through resources across all of NASA throughout the years, helping Orbital with the partnership. So it's really different way of doing business. We're sharing the cost. We are certainly not paying the full cost of the development of these new capabilities. And I think it's been very effective for us. Next chart. So our other partner, SpaceX, completed, as you know, the COTS Space Act agreement. They completed their second demonstration mission and first flight to the space station last May. That program took about 6 years to complete from the beginning. They had a head start on Orbital. A year and a half later, we awarded in the second round competition agreement with Orbital. But you can see there's a very similar design cycle in bringing in a new capability like this online, starting with design and development into test and production, and then finally the flight demonstrations. So this is telling us to create a capability like this is about 5 to 6 years. And with the successful flight tomorrow, Orbital will be on track for the ISS demo coming up in a couple of months. It's certainly taken a lot of hard work. Everybody has worked so well together between NASA Wallops, the Mars Authority, and Orbital, and all the folks at NASA. I want to thank them for getting us here to this point today, congratulate Orbital for great work and getting us here, and we're certainly looking forward to the flight tomorrow and then the demonstration to the space station this summer.
Okay, Frank.
All right, thank you very much, and thank you, Alan. And I agree, you guys have been great partners. On behalf of Mr. David Thompson and the entire Orbital community and team and the company, I'd like to again thank everyone for being here. We're very excited to be a part of this, very excited to be at this point in our history, and really looking forward to seeing it all come together in a column of flame and smoke and a little bit of steam maybe as we come off the pad. It has been a long journey to get to this point. It has not been without its challenges. One of the aspects of this, as Alan said, is we had to learn to work together in different ways between ourselves, our customer, our partners like Mars, our subcontractors even, and figure out how to do this on a commercial and cost-effective basis that's sustainable. NASA's investment of this has been very important. Orbital's investment has been extremely important, and then the investment made by the state of Virginia and by other parts of NASA have been important. So it's all going to come together and in the end provide us with a capability that we wouldn't have had otherwise. Alan and his team, particularly led by Bruce Manners and Kevin Meehan, have been great to work with. Whenever we had problems, as he said, we worked them together. It's important to strike the right balance there. We were very happy to have the help most of the time, and when we really needed it, we told you we really needed it. But when we needed to do things our own way and to make our own decisions they gave us room to do that, and that was much appreciated also, because it is actually our rocket, our spacecraft, and our program, and NASA as our customer has a great deal of say in that, but we in the end are responsible for its success. And we as a team evaluate all of that, and we take inputs from everybody, but we totally understand our level of responsibility in this, not only to the company and to our shareholders, but to the customer and the country. So it's going to be great to see this come together. And Mike Pinkston, our program manager, will show a few slides in a moment and give you a lot more detail on the launch. But I do want to say that we see this as a key milestone, improving what can be done in an industry-government partnership, and what can be done when people take a fresh look at how you can achieve spaceflight. And as Phil said earlier, there are many ways to achieve that goal. And this is the one we've chosen, and it works for us, and we're going to continue to build on that. Once we have flown this test flight, we will turn around and get ready for the demo mission in about 3 months, go all the way to the International Space Station, and I'll show you a brief video clip of what that'll look like. And then we'll proceed on from there to starting to execute that contract. Sometimes we get asked, well, you know, you only have a few million left on the demo mission there. A few million is a lot of money, by the way. But compared to the overall contract, you know, why is that important to you? Well, it's not a few million we have riding on that. It's 1.9 billion, and the company reputation, all the companies involved reputations. And so this is an extremely important achievement for us, no matter what the size of the milestone payment is. It's the whole team proving that we can, in fact, do this and do it in a different way and do it successfully. So if we could roll the video, I'll run through a brief summary of the overall mission concept, and then Mike will go into more detail on the launch vehicle itself. And I was assured I'd be able to see it this time, so I don't have to fake it. But
do we have it?
Is it rolling?
Let me check. All right, stand by. They're going to dig it up and get it.
Oh, okay. All right. In the meantime, the launch tomorrow is going to take about 9 hours. I'm sorry, 8 hours of countdown activities. And as we go through all of that, we'll be checking everything possible on the rocket, on the ground systems, the tracking systems. NASA is doing a great job of supporting us in the range, and of course Mars is doing a great job of providing the launch facility. At liftoff, it will probably not look like it's accelerating quite that fast in person, but I'll guarantee you it will be accelerating. And in about 10 minutes, in about 4 minutes, it'll expend all of the fuel in the first stage. We'll separate the fairing. The second stage will take over and boost us into orbit. And at the end of approximately a 10-minute flight, we will separate and be in orbit. On the demo mission, once the Cygnus spacecraft is separated, we'll deploy the solar arrays so that we can have power, and then we'll go through the 3 to 5 days of orbital maneuvers required to achieve rendezvous with the International Space Station. Along the way, we'll have to prove some things, such as our ability to hold, to abort, to control, and to respond to commands from the station. But once we do that, we will approach from below and maintain a fairly stately approach speed, and stop about 10 meters from the station so that the station crew can then reach us with their remote manipulator system or robotic arm. Once we're in position and stable, they will grapple us, and that's a fun time for the crew, actually. They don't get to operate the arm all that much, so they're happy to see something like that come up and demonstrate they really can use that training. And so they'll grapple us and then attach us to the nadir port of the node number 2. At that point, they'll go through a variety of checks to make sure that we are pressurized, that there's no leaks between the two vehicles, and that we have a good solid connection, both mechanically and electrically. And once that's completed, the crew will go through the process of opening the hatch and looking for their Easter eggs or Christmas surprises, and the food and clothing that we're sending up. And we won't have this much on the first mission, but we will have a lot of those bags, 800 kilograms worth, in this summer, that'll go up to the station. They'll unload it, stow it, and then they'll stow what we call disposal cargo in the spacecraft in anticipation of unberthing and deorbit. Once the hatch is closed and everything is as it should be, they will use the arm to release it, and it'll fly away under its own power and deorbit safely away from the station a day or two later. It could stay in orbit for several days or even several months if need be, depending on what its mission is once it leaves the station. But when it does deorbit, we'll fire the jets, slow it down by about 300 miles an hour. It'll re-enter the atmosphere over the Pacific and burn up at that time in very small pieces. And hopefully none of that disposal cargo or trash will make it to the Earth. And this isn't my favorite shot, but it does show that it does in fact come apart and burn up, and we can stop it there. So anyway, we're looking forward to that mission, but right now we're focused on this one. This is a test mission. There are things we may learn, and if we do see any anomalies, we'll respond to them immediately and take whatever action is necessary, either in real time or after the flight, after we analyze everything and decide what we need to do to make it better going forward. But we will learn a lot from this. It's a tremendous challenge to get to this point. I congratulate all the members of the team on reaching this point. Our folks on the Antares program, the Wallops team, Mars, and the broader NASA International Space Station program, and the other centers that have chipped in to help us get to this point. Thanks very much. And I also want to thank our legislators and government leaders around the mid-Atlantic states that have helped us achieve this also. They've been a key element in keeping it going and keeping it funded and keeping the support there. So my thanks to all of you. And with that, I'm going to turn it over to our program manager, Mike Pinkston, who used to have short blonde hair, but we've really worn him down the last few months.
It didn't take long, did it?
And Mike's done a great job with his team. They've been working really hard, including the last 24 hours, and getting ready to go. So, okay. Mike.
All right. Well, good afternoon, and thanks to all for coming out to what ought to be a good show tomorrow. I've got a few view graphs, if we could bring them up, to kind of walk us through the A1 mission and configuration of the Antares launch vehicle. Next slide, please. Okay, as you may have gathered, the primary objective of the A1 mission is really to provide a risk reduction for a demonstration of the launch vehicle capability itself prior to our first cargo delivery mission to the space station in our COTS demonstration mission. That objective is being achieved by designing an A1 mission in really all regards that is intended to be directly representative of what we're going to do on the COTS demonstration. The launch vehicle configuration is obviously the start. We also are carrying on board a mass representative Cygnus simulator that represents mass properties, the volumetric size of the spacecraft, as well as the direct mechanical interfaces. We will also be carrying on board that payload simulator an instrumentation suite that will be used to gather dynamic environments data that we can use to validate models and ensure that we know going into the demo mission what the Cygnus spacecraft will actually see in flight. Obviously, the orbital parameters are set to be identical to what we're going to be flying on the demo mission, and then all of the integration and launch operations have been scripted in order to emulate the flow that'll take place when we've got a live Cygnus on board. The objectives, maybe more specifically of the mission, is to give you some things to look for, the things that we'll be looking for to achieve out of the mission. First, on launch day, the commodity loading and countdown operation to launch. As Frank mentioned, it's about an 8-hour operation from the time we get our team on station through the checkout of all of the subsystems on board the rocket. Then we fuel the rocket and then enter a terminal count to launch. That'll all be conducted as it would be on the demonstration mission. Once we leave the pad, we'll be looking at the stage 1 flyout, including the performance, looking for nominal performance of the engine, core, and thrust vector control subsystems. After stage 1 burns out, about 4 minutes after ignition, we will separate the stage. It's actually a series of separation events where we'll separate the first stage, We'll separate the fairing, and then we'll separate the interstage that holds the second stage to the first stage. Ignite the second stage. It'll fly. We'll look at its performance as well as the performance of its thrust vector control system. And then once we're in orbit, we will separate the payload. So that's kind of it in a nutshell. If we could go to the next chart, just a few, I guess, important facts about the mission. It is an Antares 110 configuration. That's our standard first stage, a Castor 30 second stage, and then the no third stage. It is, as mentioned, a 3,800 kilogram Cygnus payload simulator flying out of the Mars Pad 0A. At the Wallops is obviously the lead range. Launch date tomorrow, and our launch window currently is 5 p.m. to 8 p.m. local. We will make a decision tonight after we get our last weather briefing on where to target. We can actually target 2 hours within that 3-hour window. So the decision tonight will be made as far as where we're going to go. Unless I see something that surprises me in a weather briefing coming up, my guess is we'll be going for the front end of that target on a 5 o'clock liftoff. The altitude, or the orbit itself, is a 250 by 303 kilometer orbital inclined at 51.64 degrees. Then, as you've heard previously, the time from liftoff through payload separation is about 600 seconds, or about 10 minutes. We do execute a series of collision and contamination avoidance maneuvers once we separate the Cygnus payload simulator, and that will continue on for another 500 plus seconds. But essentially, that'll take us to our nominal end of mission around 1,124 seconds. If you go to the next chart, please. This is a graphical representation of the fly-out events, along with a timeline down in the bottom right-hand corner. The fly-out events are essentially as I've previously described. We've got about a 4-minute first stage burn, at which point we'll cut the first stage engines off. There's a bit of a coast while we separate the stage and the fairing and the interstage, and then we will ignite the Castor 30 second stage, and that burns for about 155 seconds, leading us to an orbit insertion and payload separation at about 603 seconds. Let's see, the next chart is hopefully a brief animation that'll give you a little bit of a cutaway view of the Antares launch vehicle. Do we have that? Yeah, there you go. So you'll see the AJ-26, dual AJ-26 engines provide the first stage propulsion. They are connected to a pair of propellant tanks. The big blue one is our liquid oxygen tank, and the yellow colored tank contains RP1 kerosene fuel. The second stage is the Castor 30, and you can see the thrust vector control system situated around the top of the nozzle, along with our orbital provided avionics system. And then up at the top is a 2-piece fairing that shrouds the payload during atmospheric flight, and then inside that fairing is a Cygnus mass simulator, or on the demo mission, a real Cygnus. So next chart, please. Providing just a couple of pictures to show you what some of that hardware looked like in the HIF. You can see the Cygnus simulator waiting for the fairing to be mated, and then a picture of the entire launch vehicle being lifted and transferred over to our transporter erector in the horizontal integration facility. And then the last two photos are a couple of pictures from just a couple of weeks ago with the rollout on the morning of Saturday the 6th, followed by the erection to vertical on the launch pad, and that's where we sit today, running through our final last few preparations for launch tomorrow. So with that, that's a brief description, and I think it's range guy.
Yes. Good afternoon. As test director here at NASA's only launch range, I am responsible for ensuring the pathway is clear for the Antares to have a safe flight to space. Early today, our center director granted us the authority to proceed with tomorrow's launch operations, which is the final go for executing our launch plans and the countdown. Have my first slide, please. From the data and communications perspective, we have assets in Antigua, Bermuda, Coquina, North Carolina, as well as here on the Wallops range supporting the Antares launch. All assets have been configured, tested, and verified ready to support launch operations. At this time, we have approval from all external agencies responsible for controlling the airspace for flyout, and we've issued our standard notices to airmen. I personally like to thank Mr. Ed Gannon from the FAA, Adam Baker from the Joint Space Operations Command, and Ben Nelson from Fleet Forces Vacate for their assistance and responsiveness regarding area clearance. My second slide, please. For mariners, the initial hazard area is an odd shape that extends out about 90 miles. Notice to mariners issued this week requests that boaters coming from the north remain north of 37 degrees, 50 minutes, and east of 75 degrees. And those boats traveling from the south remain south of 37 degrees, 20 minutes, and west of 75. Our partnership with the Coast Guard and the Virginia Marine Police will assist us in clearing the area prior to launch. And I personally like to thank all of our area mariners for the support and cooperation. Finally, I'd like to end with our forecast for tomorrow. Currently, the weather officer reports that the winds at T0 will be out of the south between 8 and 13 knots. Visibility would be 7 miles with low-level cloudiness with a slight chance of showers. Putting all that together, it looks like from the T-minus 48 hours, we have about a 45% chance of favorable weather for launch because of the low cloud ceiling and the possibility for precipitation and thunderstorms. On a personal note, for me, this is both exciting, optimistic, nervous, and just ready to execute this mission. I'd like to thank the folks in the field, both at Antigua, Bermuda, and Coquina for their support getting ready for us and all the checkouts and the tremendous work that they've done for us this far. On that note, the NASA Wallops Range is go for supporting tomorrow's launch, and I'll turn it back over to Josh for questions.
Okay. Thank you, John. We're going to start here in the room, and then we'll take some questions from the phone. So let's see. We'll start with Dan, then we'll go down this way. Right here.
Hi guys, thanks for coming down. Thanks for having us again. This is an Alan question, I think. We know that the contracts for cargo delivery will run out and all the flights will hopefully have been successful before the space station is done with its mission. So when do you anticipate you might go about procuring more cargo flights? And do you think that it's credible to have a new participant in this without doing, say, another COTS-like program?
Well, the planning is underway right now to continue the resupply services to the station. I don't have personally the specifics on that, so I'm afraid I won't be able to answer specifically how we would go about it, but definitely the planning is underway so that we would have continuous service of resupply to the space station after these initial contracts run out.
Okay. Tarek?
Thank you. Tarek Malik with Space.com. And I think my question is for the Orbital representatives. You mentioned this is a test flight. You know, that we're going to see how it goes tomorrow. But I'm wondering what your confidence level is based on what you've seen, the work you've done on the vehicle over the last 6 years, of success tomorrow and the ensuing flights later this year. Thanks.
Well, my confidence level is very high. I joined Orbital about 5 years ago, and having watched the team work on this, on the development, on the testing that has preceded this, and then having participated in the practices and rehearsals in the control center and watching the Orbital team as well as all the supporting teams work together, I have a lot of confidence that all of that's going to go well. The hardware is ready. It's been through its own testing, and I think that we're going to see a nice show tomorrow, as Mike said. So my confidence is high. I don't know what number you'd put on that, but I feel good about it. Mike, Mike, program manager, how do you feel about it?
Well, we wouldn't be here if we weren't highly confident this thing's ready to go.
That's right.
Hi, Ken Kramer for Universe today for Frank and the Orbital representative. Since this is an NPLM design, I wonder if you could talk a little bit about the evolved versions of the Cygnus. You brought up in the last briefing about going beyond Earth orbit. I'm also wondering about, you said you could say 30 to 90 days. What about longer term? If you increase the shielding, could this be a permanent addition to the space station?
Well, a lot of things are possible, and you know, we're really focused on this flight for tomorrow, but looking long term, the Cygnus cargo module is based on the NPLM design built by the same company. The spacecraft itself, however, the service module, is based on our legacy spacecraft with a lot of enhancements to make it more redundant and more reliable. But it is designed for operating in space longer than the current 30-day requirement. And with some additional certification and testing, I feel sure we'd be comfortable going beyond that. And I think, as I mentioned earlier, we probably could go as long as a year if we had the right amount of fuel and did the other certifications necessary for the hardware. That would require a mission. That would require people wanting to use it for that long, and there are folks interested, but we don't have actual customers yet. In terms of using it as a habitation module, we'd have to upgrade a number of things to add redundancy, add shielding, add life support systems, of course. And so right now it's a very well-designed cargo carrier, and it's single purpose as a cargo carrier, but very efficient. We could evolve it to other things if those missions start showing up on our radar screen.
Okay, down here.
Jason Potter with Wired, and for either of you, can you describe a little bit more in detail of what the dummy payload is constructed of, what it's made of, how is it solid, is it empty, is it a little detail about that?
Go ahead.
Yeah, just quickly, it's metallic. It's not solid. It's a framework with some panels around it, so that when you saw the photo, it actually looks like a big white cylinder. Those are white panels around the outside of it. Within it, we've got some instrumentation and the like of that to measure acoustics and vibrations and thermal environments, again for model validation and to provide some direct measurements of the environment the Cygnus will see on its ride up on the demonstration mission. There's also a couple of secondary payloads that are attached to there's a couple of those panels that are left open with a couple of small secondary payloads. Frank, you may know more about the secondaries than I do.
We have 2 Peapod dispensers for some CubeSats that we'll deploy shortly after separation, and that'll give us a chance to get some additional, give additional rides to other users.
What's the mass made of?
It's probably aluminum.
It's aluminum.
Right, Frank? Yeah. It's mainly a framework of girders designed to come apart once it re-enters the atmosphere and burn up quickly.
Okay, down here.
Hi, Stephen Clark with Spaceflight Now. A couple of questions. First, could one of you go over the launch, the strategy for launch opportunities over the next few days, with the weather being iffy, at least 2 other 3 days ahead? Would you try 3 days in a row, or would you stand down after a couple of opportunities for a crew rest or for some hardware reason? And I have a follow-up. Yeah,
I think we will almost definitely take a shot the first 2 days. Looking at the weather briefing, the weather on Friday looks really unfavorable. The other consideration, as you mentioned, I think the other big consideration is crew rest. If we get into, and this is all somewhat dynamic, if we get into a situation where we've actually begun fueling the vehicle and then have to detank the vehicle after a scrub because of weather, then that makes for a very long day for our team. And if we were to do that 2 days in a row, we probably would be looking at trying to get a day of rest in there somewhere. But again, I think it's going to be a dynamic decision process as we look at the weather on any given day. I don't think there's anything hardware-wise that necessarily would require us to take a 48-hour recycle. But certainly, if we get to certain points in the count, both crew rest and consumption of commodities, if we get very far down in the count, we can consume enough commodities to where the Mars team would need a full day to turn that around as well. So not a very specific answer to your question, but it is going to be kind of a dynamic process that takes those factors into account.
Okay, thanks. And one more question for Mike or Frank, either one of you or both of you can address this. Can you talk about the fairing for Antares and any changes you may have made to the fairing design? How different is it from the Taurus design, for example, and any changes you made following those accidents? Thanks.
Mike can give more specifics, but I'll just say that in general, it's a similar design. It's fairly common to orbital launch vehicles. However, there have been modifications to increase the probability of everything working the way it's supposed to, based on lessons learned from the previous Taurus launches. And we feel very confident in the components that we have, the approach that we've taken, as well as the suppliers that participated in this one, and the plan we have for this flight. So, Mike, if you want to add
yeah,
a little bit to that.
I'm not sure. There are a lot of changes. Obviously, as you can imagine, as we went through the mishap investigation coming out of the Taurus XL. As Frank mentioned, this is the frangible joints are in particular are a common product that we use across our fleet, and there were a number of changes that were that came out of those investigations, both in terms of increasing design margin in the design, as well as additional testing and additional process controls on the materials that are used as delivered from our suppliers. I can say that we have implemented all of those corrective actions, including additional measurements on materials properties. There were some actual design changes to the design of the joint. And then some additional and more rigorous testing. All of those were corrective actions were employed on the Antares frangible joint designs, and they all passed and are ready to go.
Okay, we've got one more question in the room, but let me go ahead and get everybody on the phone lines to stand by. So Nick Tabork, you're going to be up next right after Robert asks his question.
Hi, Robert Perlman with CollectSpace.com with a question for Frank, or I think maybe John. Different launch teams have different traditions. The JPL teams have their peanuts. The shuttle team had their beans. Does Orbital have any traditions, or if this is a maiden flight, are you planning to initiate any new traditions for Antares?
We'll see what develops.
As far as the range, the FSO and I currently wear bow ties. That's our working tradition.
If we get off the pad, we'll all pay attention to what color socks we wear.
Okay, let's go to the phone lines. Nick Tabork with Bloomberg. Can you hear us, and are you ready to ask a question?
Yes, thank you. Just a couple quick things. So can you mention again, how long will the replica be in orbit transmitting information before burning up in the atmosphere? And then can you mention until through which year are the resupply contracts, those 8 missions, is that through 2015 or through 2016?
The Cygnus simulator will remain on orbit for approximately 2 weeks, plus or minus a little bit. It will only transmit information up until separation. At that point, it'll lose power and we'll go dead. So we won't hear anything else from it after that point. And what was the other question?
The CRS contract.
Oh, the contract is for 8 cargo delivery missions beginning this fall. That will probably take us through sometime in 2016, depending on our launch rate as well as the rate at which the station will ask us to deliver. So it requires both parties to agree on when the cargo delivery is required.
Okay, Irene Klotz with Reuters.
Hi, thanks very much. I have a couple questions for Frank. A follow-up from the other briefing. You mentioned possible future missions for Cygnus. Could you also please describe what might be in store for Antares, if you have any customers, and what this test launch might do. And then I have a couple of general questions about the spaceport itself. I don't know if any of you all have this or not, but just what the state and NASA paid to develop the Mars spaceport. And I regret having to ask this question, but did you guys have to do anything with upgrading security in light of the attacks in Boston yesterday? Thank you.
You want one person to answer all of those?
Go for it.
I'll start. Let's see. The first one was the
Other plans for
beyond Cygnus.
Yeah.
For Antares, we don't have any customers on contract yet. We certainly are talking to a number of folks, including NASA, for using Antares for deploying satellites into particularly low Earth orbit, but also beyond. We feel pretty strongly that a successful test flight here and also a successful demo later will help us in our marketing a great deal. And I'll just leave it at that. Some of our business development folks are out here in the audience probably drumming up business as we speak. And it'll help a lot tomorrow, I know, Mark. As far as security, I'll have to ask John to address that.
There's been no additional measures taken because we're already at a posture now, because we have hazard areas up. We have manned guards at every station, so there's literally no way to get access to the pad to those areas. So there was no need to take, I guess, additional measures or a different posture for this op because we're already there.
And as far as the expense of the pad development, et cetera, I don't have those numbers off the top of my head, so I'd recommend contacting NASA Public Affairs and seeing what information they have available. Thank you, Josh.
All right, let's go to James Dean with Florida Today.
Thank you. For Culver Center, Pinkston, an AJ-26 had a mishap, I guess, a while back during testing at Stennis. Could you explain what happened and what you needed to do to correct that issue, and whether there are any engine concerns you'll be keeping an eye on since then as you launch tomorrow?
E4.
I guess we're talking about the E4 mishap.
Where we had the failure of the fuel line.
Yeah. Well, that obviously prompted a very in-depth and detailed investigation, and what came out of it, and I think primarily in simple terms, is a series of additional inspections that we have employed on all of the future engines, obviously including the engines we're going to fly tomorrow, and they have some engines have shown indications that would require repair, and we have the techniques developed to repair those engines. Some of these indications are acceptable as is, but we've got now all the rigorous engineering behind it to show that those any of those indications are acceptable for flight. So that process has been applied to these two engines, and they've been deemed flight worthy, and passed their acceptance testing at Stennis, and are good to go, ready to go.
Okay, let's go to Shane Harris with Washingtonian Magazine.
No question.
Okay. Bill Harwood with CBS, are you there?
Yeah, I'm here, Josh, and I'm not sure who this is for, maybe Frank or for Mr. Pinkston. Just continuing on the engine theme for just a moment, can one of you guys tell us a little bit more about what the AJ-26 or that brings to you guys? I mean, the advantages the engine offers, and a little bit more about what you do to refurbish these guys or upgrade them from the stockpile state that they came, from Aerojet in. Thanks.
I'll hit it programmatic. What the AJ-26 brings is an engine that was developed quite a while ago, but developed under a program that was very robust and intended to be used many, many times with multiple articles built during the time frame when the Russians were intending to go to the moon. The engine did fly on some very short flights, but the flights were not successful due to other problems not related to the engines. They also have thousands and thousands of seconds of test time behind them, tested in a wide variety of conditions and power levels. So we know the engines are robust. As we went through testing, we did discover that there were some effects of of aging since they'd been in storage for a while, including some stress corrosion cracking, and that's what we're correcting with the weld repairs and other inspections. But what they bring is an engine that produces a lot of power, has a great deal of performance, and satisfies our needs for getting payloads to orbit. And we also have the legacy of proven design that we can depend on. Mike?
Yeah, as far as how the engines are taken from their previous state to a flight-ready state for us, it's it's a number of items. It's some reconfiguration, in particular, provide the gimbal mechanism that allows us to vector the engine in flight to provide the thrust vector control. Some upgraded and modernized instrumentation, as well as the one-shot devices, the pyrotechnic devices that are used to ignite and bring up the engine. And then, obviously we go through a very rigorous, our partner Aerojet goes through a very rigorous process of inspecting and testing the engines, including the hot fire test at Stennis before we declare it flight worthy and bring it out here to Wallops to integrate on an Antares launch vehicle.
Okay, that's going to do it for the phone lines. There's some follow-ups here in the room.
Since this is Doug Money, TMC Satellite Spotlight, since this is a commercially run mission, who holds the key for flight termination in case of an incident? Is that NASA or is that Orbital? Where does that responsibility lie?
NASA.
NASA owns the range, and so they're ultimately responsible. They talk to us a lot, though.
Okay, back here. Hang on. Try it again.
ClearsHaver.com. I was wondering about the viability of upgrading Cygnus to re-entry capability.
Cygnus, as it's currently designed, doesn't have a re-entry capability. However, we are looking at ways to either modify the system or bring on board a different type of design so that if NASA would like for us to explore that possibility in the future, we can do that. And there's several different ways we could go with that, but right now we don't have a contract or even a study to do it, but we know that in the future they're going to want more and more of that capability, so it's certainly something we're looking at very, very carefully, Alan.
Okay, is that it here in the room? All right, that's going to wrap it up for us. We want to remind you that our live coverage of tomorrow's launch will begin at 3 p.m. Central Time, 4 p.m. Eastern Time here on NASA Television. You can also stream it live on the web at www.nasa.gov. Of course, for all the latest on tomorrow's activities, we invite you to log on to www.nasa.gov/orbital. There is a media resources section on that page. Alan's slides are up there. We'll try to get Mike and John's slides up there later on today as well, so you guys can have those. Of course, for all the latest, log on to nasa.gov. Follow us on all of our various social media accounts, and we'll see you back here tomorrow. Thanks a lot.